All right, welcome everybody to our next Pygame lesson. We're continuing on with our SpongeBob game, and last time we went through our code and kind of updated it to kind of offload some of the coordinate management for where our surfaces are to Pygame. So what that meant with the code was that in addition to having these things like here, like SpongeBob, which was the surface, we also created a rectangle, an invisible kind of box that matched exactly how big the image was, but it also let us do things like track coordinates from different places a lot more easily. So we could now, rather than just with the image, all we could track was the top left point of the image. But now that we have this wrapping rectangle around it, we can now ask Pygame for just the top coordinate. We could ask for its top right, its bottom right, all the way around. There's actually 9 different points that we could have, including the center. We also had the properties for the X and Y, where we could just adjust its X and Y coordinates that way. So we had those all set up, and just to kind of review where our game was at this point, we didn't make any visual changes last time, but everything kind of behind the scenes is kind of ready to do some different things, in particular collisions. So we're going to look at coding some collisions to make sure SpongeBob can't go off the screen anymore, and then we'll also try to get a notification to see when the starfish and the pineapple collide with SpongeBob. So this would be really difficult without those rectangles. The rectangles make the logic a lot more simple. So let's get into that. Okay, so we are going to start. Let's start with it's not technically a collision, but we're still going to use the properties of those rectangles to keep SpongeBob from going off the screen. So all of that stuff for the key pressing is right here. So this was like line 54 to 64. If you're following along, it'll match the line numbers exactly. If you don't have all the exact same comments, this is around the range you're going to look for yours. Okay, so let's look here. If we had this structure in the code where first we figure out, we use Pygame to check what key got pressed. It's looking for, it'll detect any keys, whether it's the escape key, the 6 key, but we were in particular looking for when the key is equal to A, D, W, or S. If those were the keys, that was where we tied the movement to, right? But what we want to say now is we don't always want to be able to move left no matter what, right? For example, if we press the A, which is moving SpongeBob and Patrick to the left, if we're already at the left side of the screen, we actually don't want to do any changes at all. Okay, so what we're going to do is wrap this in a conditional statement. So what we're going to say here is that so we're looking at the X coordinate for SpongeBob. So we're going to use that same SpongeBob rect.x. So if SpongeBob's rect coordinate is, if we look at the screen, so I'll use this kind of window here as our screen. The top left, this was our 0, 0 coordinate. And as we go down, that's a positive y value. And as we go to the right, that's a positive x value. So if we're at the left side of the screen, this is when the x is equal to 0. So we want to decrease as long as the x coordinate is still bigger than 0. Okay, so we're going to say only as long as the x coordinate for SpongeBob is still bigger than 0, then we'll subtract. If that's ever not true, then we're going to disallow the left movement. So let's see what's going on here. So I'm getting an error. So let's see what that error is showing up as. Oh, I wrote an if statement. So every kind of code block needs to start with that colon. So that's what I'm missing there. So that red line goes away, and now we should be able to get this working. So I'm going to run this, and we're testing. So up and down, there's no change. Same thing to the right. But as I go to the left, I should hit a hard stop. So that is working there. I'm holding the A key right now, and SpongeBob and Patrick can't go further left. Excellent. So that's actually a pretty simple way to get that kind of barrier worked out. And again, that's easiest when we can deal with these rectangle positions, one of the 9. Because as I move to the right, I want to check that it's not even that it's X coordinate or Y coordinate. I want to check maybe it's top right or its right position to make sure that it's not bigger than the screen width. Okay, so let's go ahead and do that. So I used SpongeBob Rect here. Let's maybe change this since I'm going to use let's swap this out for left. So I'm going to use the positioning here. It shouldn't make a difference in the code, but left will just update or look for this left side value here, which matches the X coordinate because SpongeBob X and SpongeBob Y are by default tracking top left. But just to make the code a little bit more consistent, I just want to give that a swap out. Oops. I want to swap that out for rectangle left. So before I make any other changes, I'm just going to make sure that works still. So if the left, there we go. So that's just fine. Okay, I'm also going to add I'm going to add an else here as well. Let's just wrap here. Okay, so we're going to have an else because there is a possibility, because we do have this variable called sponge speed hanging around, right? Every time I move SpongeBob, it's moving 5 pixels. So depending on how the math, there is a possibility. I didn't see anything there, but there's a possibility that maybe you'd get a little bit of SpongeBob or Patrick, maybe a little bit of it would get clipped off. So what I'm going to do is add just one other bit here. I'm going to say that if this is not true, so we're going to say that SpongeBob rect dot x, we're going to set this exactly equal to 0. Okay, so if we move left and then we can't move left anymore, if we're currently dealing with a negative coordinate, then we actually just want to make this exactly 0, just to avoid kind of clipping part of the image off, and that's kind of where it's getting stuck. So I'm just going to run this one more time. And when we move SpongeBob, so again, we weren't getting anything clipped off, but now we're just sure. The exact left of Patrick's elbow is touching the screen, and that is good. Okay, so now we're going to get into the next one. So we'll have a very similar code block on the else. So we want to say, oh, sorry, that's here when they press D. So this is moving to the right. So again, we don't always want to move to the right. So we want to say if SpongeBob rect and it's right side. If the right side is ever greater, I'm just going to add a little space here. If the right side is ever greater than the screen width, that was the variable we had just tracking the width, then, or sorry, we want to make sure, we only want to add if it's still less than. So if the current right side is still not at the screen, it's less than the screen width value, then we can add more to its x coordinate. Otherwise, if we are at the limit, or if we're over the limit, then we want to say that SpongeBob rect dot, well, let's say here, can we, let's try this one, dot right is equal to screen width. Let's try that. So X and Y, again, that's kind of tracking the top left, I believe, by default. But let's see if this works here. So let's move over to the side. SpongeBob is now locked, cannot escape the right side of the screen. So just for consistency, again, I'm going to change my top coordinate there with SpongeBob X. I'm going to change these both to, I'll change them to the left and right, just so it all matches. So we're going to say SpongeBob left. Even though the code was working just fine, this is kind of just a consistency, a readability preference that I'm trying to use here. Let's just make sure nothing is broken. Still locked. Still locked. Excellent. Okay, so now we'll just make the same changes for the other two movements. So it was the W and the S. So W is the thing that normally makes it move up. So we want to write a similar if condition. So if SpongeBob rect, and we're looking at its top here. We want the top to be greater than 0 if we want to move up, right? So we want to say that in our code. So we want to make sure that before we kind of take away to move SpongeBob and Patrick up, we want to make sure that its top value of its rectangle is still greater than 0. Then we can run that code. Otherwise, if SpongeBob and Patrick has a top value of either 0, they're at the top, or maybe they've gone negative somehow, again, because of that sponge speed being 5 and not just 1, we want to set the top, spongebob.rect.top, we want to set that equal to 0. And I'm going to do, again, the same kind of matching here where I'll get rid of the y value, and we'll reference the top value instead, just to keep things a little bit the same. So let's run that just to make sure we didn't make any mistakes. So it's the top that should be fixed now, and that looks good. So now the top, the right, or sorry, the left and the right, and just the bottom left that we need to kind of keep within the same region. But everything is going to be the same now, so we got to look for the line of code. It's at 72 for me, where we're detecting that the S was pressed. And it's the same sort of thing here. So it's the bottom. So if SpongeBob rect.bottom, if that is less than the screen height, right? If there's still room to go, we're not quite at the bottom of the screen yet, that's when we want to say we can add more to bring SpongeBob and Patrick down. But if they are either already there or they've kind of gone off the screen a little bit, we're just going to have a little bit of code here that says SpongeBob rect.bottom. That should be, I've made a typo somewhere. Here it is, SpongeBob rect.bottom. That should be exactly 0 if they've gone potentially off the screen. So I'll just make that same change here, bottom instead of the Y. And let's run that. No errors, that's good. So all 4, whoops. Oh, there, I guess I almost did like a Pac-Man thing where you can go off the screen and reappear at the other side. That was not intentional. I didn't do that on the right? So I did a little something careless there, which absolutely happens when you feel like you're in a groove and you're doing the same thing over and over again. Let's look at how I did that when I did the going to the right. In my else statement down here, I said that if they've kind of gone off the screen, don't set it equal to 0. I said set it equal to the screen width. So that was my mistake over here. When they're going to the bottom, they're actually at the screen height. So I shouldn't set it equal to 0 because that will put them at the top of the screen. So I need to say if they've gone off the screen, just kind of throw them right at the bottom. So this now should get them locked. That kind of error is great to see because they happen all the time. It's just when your brain gets a little bit careless. But now SpongeBob is locked, trapped under the sea with the spiky starfish and the spiky pineapple, ready to cause some damage. Okay, so we've been using those rectangle properties, again, those just by making those rectangles to match with our images. Now we can more flexibly talk about the different positions of the rectangle, which is excellent, but we still haven't technically done any collisions. So now we're going to pivot to looking at, okay, what if the rectangle we have for the pineapple is on top of or overlapping with SpongeBob's rectangle? So we're going to get, let's put this, so we've got again, we're in our while loop here. This is the whole game loop. We drew our images, we checked for new events, Then we had kind of the different movements for the keys for SpongeBob. Then we had our obstacle movements. So I think it kind of makes sense now here to add some collisions. Okay, so let's call this collision checks. So this uses a method that's built into Pygame. It's called collide rect, and it takes in a rectangle to check with. Okay, so let's do a example and then we'll kind of talk about how it works. The methods and the instructions are always written kind of abstractly, so it's maybe easier to see it with an actual example. So we want to check, let's check if SpongeBob is colliding with the pineapple to start. Okay, so we'll say if SpongeBob rect dot collide rect, collide rect with the pineapple rect. Let's just do a print statement here. We'll just say print hit by pineapple. Okay, so we just have an if statement here. So we are calling this like collision function on the SpongeBob rectangle. And we're checking if the SpongeBob rectangle has collided with the pineapple rectangle. Okay, so this would work in the opposite order as well. I could call the collide rect function on pineapple rect if I wanted to, and check if pineapple rect is colliding with SpongeBob rect. That would do the exact same thing. But just in terms of like which is the more important rectangle at this point, SpongeBob is like the main character. So I'm just gonna write all these to check if SpongeBob is colliding with the pineapple. So even though the order could be swapped here and nothing would change, I think this is probably the best way to write it just because SpongeBob is the player character. So let's just check to see if that worked. So this is just like 1, maybe 2 lines of code to do a whole collision, which mathematically actually is fairly complicated. So we are definitely taking advantage of the Pygame game engine to do a bunch of that hard work off for me. So you can see that the pineapple is filling up my terminal window here. So it's not only detecting one collision, it's detecting like, I don't know how many there are there, but that looks like maybe 10, 20, I'm not sure, but it's filling the whole terminal very quickly. So that creates a bug that we'd actually want to fix. Because if you were playing a game and let's say you had 5 hit points, if you got all of them drained away because you got hit like 30 times by a single pineapple passing through once, that's obviously a problem. So that's something we can fix later, but not in this video. We're just going to get the collisions working and making sure that they are acting appropriately. But so far the starfish, no change, but the pineapple is working. So let's just add another spot here under the collisions. Let's say if SpongeBob rect collide, so collide rect, if it's colliding with the starfish rect, if those are colliding, then what do we want to do? Let's just do another print statement. We'll say hit by starfish with an exclamation mark. So now these should both register now. So hit by pineapple, hit by starfish, and now we can kind of see what's going on. And if we have just the height just right, we're getting hit by starfish and pineapple, which looks pretty good. Okay, so we're almost at the end here. I'm just going to add in one more little bit here because with the starfish in particular, we had this other variable because the starfish was the one that bounced across the screen, right? We had this starfish right move is true. So it's moving right. If this Boolean is false, then the starfish is traveling left. So what I'm going to do is I'm just going to add one extra bit here. Now we are registering like a ton of collisions with the starfish, so this might not work perfectly all the time, but I'm just going to try here and say starfish, lowercase f, starfish move right, I'm going to say is equal to, I'm going to do the same thing. I guess I didn't have to do it up there. So I'm just going to tell it to swap. So I'm going to say starfish move right is equal to not starfish move right. Now, I think in Python, I think I'm writing this in a kind of different language. So the exclamation part is how we would do not in a different language, like with our Arduino. But what we want to do in Python is just say not. So we just spell it the not instead. So this should, if we get hit, what I'm hoping is that this will kind of change its direction. And I think this might actually work okay, because the first time it makes a collision, it should just automatically go the other way. So this might not compound with that bug that we have with the multiple collisions. Oh, starfish. Did I have something there? Starfish, move right. Maybe I had a typo somewhere. Let's see here. Star move right. It wasn't starfish. Okay. So I was using from Python's point of view, I was using a completely different variable by calling it starfish move right. So it was just star move right. So this hopefully will not crash. And there we go. So now we've got a working, just move this a little lower. We got a working visual collision here where now the starfish is also treating. So now we've got there's the bug. So when we have all these multiple collisions, the starfish, we can trap it. But if it's just hitting the side, this is kind of maybe the intended behavior. And if you think about a game like Pong, where they had a paddle and they would change the direction, I mean, we kind of have a just left to right version of Pong going on with SpongeBob and this starfish. So there is kind of a really nice version of collisions, and we can kind of trap it. Again, we'll try and get it in there as tight as we can, and it's just bouncing back and forth. It's really kind of trapped there. Okay, so there are obviously a lot of different interesting things we can do with these collisions. With this kind of code, you can, rather than doing print statements about getting hit, you could do things like tracking health points. Maybe you don't want to get hit so many times. We do definitely need to fix the bug about registering 20 collisions when there's only one, but there's a lot of possibilities that can open up here. You can, just like how we've kept SpongeBob from going off the screen, you could do some collisions and make like a maze kind of idea. If you make some different rectangles that kind of are your maze boundaries, you could use them to then figure out, how do I keep SpongeBob inside of the maze, and then you have to navigate the maze to get out. So there's a lot of different possibilities that open up when you can code a collision. But that's going to be the end of this video. In the next lesson, we're going to look at fixing that bug for the multiple collisions, and we'll also do something like getting some text on the screen. Okay, that'll be a nice extra bit as well that you might want to make a more fun game. But that's going to be it for this lesson. Thanks for watching.